-1 and -6. That's right. X equals -1 and -6. And another name for them is x-intercepts. So if you have your phone out, if you can put the phone away, please. So -1 and -6 is where the graph crosses what? The x-axis. Good. So those are zeros. So let's skip to this one. What would the zeros for this one be? Number 3. X is equal to 2 and 5. And then what about number 2? Do we have any zeros on that one? No, it doesn't cross the x-axis. So it's possible for a parabola not to cross the x-axis. In that case, there would be no zeros. Is it possible, do you think, that we could have 1 0? Yeah, for a parabola that faces up or down, what might that look like? Do you have a guess, Leah? So we're looking at a parabola. Thank you. That's right. Very good. So our parabola could be right here like this, just sitting on that x-axis. Then it only has 1 0. So on to the next examples. So we want to find the vertex, the zeros, the domain and range of each. And then we're going to make sure we graph using 3 points. So the equation now. How can we find the zeros from the equation? Good vocabulary. So let's go back here. Each of these points would be -1 0. And -6 0. These points would be 2 0 and 5 0. What do those points all have in common? The 0 where? The y. So our y needs to be equal to 0. So what we need to do when we have an equation is we need to set that y value equal to 0. So we're going to first set it equal to 0. And 0 is equal to -x minus 7 times x minus 5. And then how do we solve that? 0 product property, that's right. So before we do that, though, what should we do with that negative?
Divided by -1.
Yes, that's the easiest thing to do to get rid of that negative. We could distribute it there. It's easier just to divide both sides by -1. So then we get 0 equals x minus 7 times x minus 5. And now use our 0 product property. X minus 7 is 0 and x minus 5 is 0. So we get x is 7 and x is 5. So we're going to put a point at 7 0 and 5 0. So that's 2 points. We need to find our third point. So how might we find that third point? What is the name of that third point? So we want to find that axis of symmetry. Very good. Good vocabulary. Where is that axis of symmetry located in relation to those two? Right in the middle. So we have this line here that's our axis of symmetry, and it has an x value of 6. So we know our vertex has an x value of 6. We need to find our y value. So how do we find the y value of the vertex? Yeah, substitute it into the equation. So we have, and we have to go back to our original equation up here. Oops. Yeah, that equation right there. So we want our equation to be y equals -6 minus 7 times 6 minus 5. How do we simplify that? That's the simplest way. Yeah, simplify what's inside those parentheses first. So this would be a -1, this would be a +1, and then we're just multiplying. So we have a negative times -1 times 1, which is 1. So our vertex is 6, 1, 6, 1, so there's our third point, and we know that it faces downward. Does that make sense that it faces downward? We want to look at our original graph, our original equation. Does it make sense that the graph is going to face downward? Yeah, because that's got an A that's -1. So remember, when that A is negative, it means it faces downward. So, domain.
Negative infinity and positive.
Yeah, good. Negative infinity to infinity. And what about the range? Guys, I'm almost done. Negative infinity up to +1. So we're looking down here. Down here are negative values, and then it goes up to the -1. So that's our domain and range, and then we're done with that one. Let's write what the zeros are. Zeros are 7 and -5. Excuse me, 7 and 5. Okay, so what do we do on number 6? So we did this before, and we called them x-intercepts, and I knew that a lot of you would forget about it, so that's one of the reasons we're doing this again today. So you could find the vertex. The problem is we have to find our zeros. So we would rather not have to find a bunch of points from there. So yeah, what can we do to find it?
Just factor it.
Yes, so factoring it will help us find the zeros right away. So we look at what multiplies to 15, that adds to 8, and what would that be? 5 and 3. So we have x plus 5, x plus 3, and then we're finding our zeros. So we set that y equal to 0, y value equal to 0. And then use our zero product property. And so we get x is -5 and x is -3. And those would be our zeros. -5, -3. Where is the vertex located in relationship to that? That's right in the middle, straight through the middle. So we draw our axis of symmetry. We know for our vertex, the vertex has an x value of -4. So we're going to, in our equation, here I think is the easier one to use, this here. But it doesn't matter, you can use any of them. So we have y, you could use this one here also if you wanted to. So we have y equals -4 plus 5, and -4 plus 3. So that's 1 times -1, which is, what's that equal to? One times -1? -1. So our vertex is -4, -1. And then we can draw our parabola. And again, some of you wanted to use the changing it to a vertex form, which is fine. It's just we've got to make sure we get what those zeros are. So you'd have to make sure that you have exactly what those values are. So almost done. What's our domain? Do you know what the domain is? Yes, it is. And then our range on this one, it goes from -1 up to positive infinity. Bracket on the -1. Does that make sense? Okay, so you have notes on the other side of that page, and excuse me, homework on the other side of that page. So that's your homework right there on the other side.